Okay, let's work 5.53 from the textbook. This problem asks us, how many grams of phosphorus, P4 solid, is going to be necessary to react with 35.5 liters of oxygen gas held at standard temperature and pressure. Okay, so this is a kind of a fun problem because it involves gas loss, dealing with how much oxygen we've got, and it also involves a reaction and stoichiometry. You can see that the reaction's already been balanced for you, so you don't need to do that. So how in the world can we sort through this? Right? Well, it asks us how many grams of this do we need? And right now, honestly, don't know. But we can probably come up with a framework for figuring out how much we need, because we're told how much oxygen we've got, okay? We're told that we hold our sample of oxygen at STP, standard temperature and pressure. Now remember, that's 1 atmosphere in 273 Kelvin. That's what defines that, okay? We're told that we've got 35.5 liters of that gas under those conditions, okay? We're going to react these things, we're going to make this product. Basically what the problem's asking us is, how much of this do we need to consume all of our oxygen, okay? It's sort of just like a stoichiometry problem, okay, that we learned about in previous chapters, except now we're extending upon the concepts because we're using the gas laws. So let's think about this for a second. Can I use my PV is equal to nRT relationship to figure out how many moles of oxygen is present in the sample? I think we can. If we rearrange this to solve for N, which is our number of moles, I would have PV divided by RT. So I can solve for N, my number of moles. Reason being is I know that my pressure is 1 atmosphere because I was specified standard state for STP. I know my volume is 35.5 liters. Okay, so I can plug in my P and my V. My R is that universal gas constant, 0.082, provided I'm using atmospheres and liters. My temperature is 273 because I'm operating at STP. So I plug in all those numbers, and I do the math, and I find that my sample of oxygen contains 1.5858 moles. That's my N, solving for N. That's how many moles of oxygen I must have given these conditions, considering oxygen behaving as an ideal gas, right? So this makes the problem a little bit easier, because if I told you that you've got 1.5858 moles of oxygen that reacts with how many moles of phosphorus, maybe you could have more success at solving that. And that's sort of where we're at this point in the problem, right? And now I know I got 1.5858 moles of oxygen. This just becomes a stoichiometry problem, where I'm going to multiply by my conversion factor that allows me to convert between moles of different substances. Now, the stoichiometry of the balanced chemical equation says that for every 5 oxygen, I only require 1 phosphorus, okay? So basically what that means, if I'm doing my math and converting into moles of P4 solid, I got to divide by 5. If I do that, I get 0.31716 moles phosphorus. Again, I'm not keeping track too much of my sig figs here, okay? But 0.31716 moles of phosphorus. This is how many moles of phosphorus it's required to react with 1.5858 moles of oxygen in accordance with that stoichiometry. So this tells me an amount of phosphorus that I need. Now, the thing is that the question wants me to answer in grams. So I only have to do one more step here. I only need to convert my moles of the P4 into grams. So I take the amount that I've got, 0.31716 0.16 mole P4. And I'm going to multiply by grams per mole. Now notice that this is P4, okay? So the number that I have to put in the numerator here is 4 times the value from the periodic table. Now if I just look on the periodic table for phosphorus, element number 15, the number that I get is 30.97. Now I don't want to put that here, okay? The reason being is because my formula specifies P4 comes packaged in that way. So I need to multiply 4 times 30.97, which yields 123.88 gram per mole for the P4. So the number that I have to put here is 123.88 grams per mole. I do this multiplication, yielding 39.3 grams of P4 that is required to make this reaction work. Okay, so 35.5 liters of oxygen at STP should react with exactly 39.3 grams of P4.